Hey guys, welcome to this session on how to become an SQL developer by Intellipaat. In this session, we'll try and demystify what an SQL developer is and how you can become one. Before we begin, click on the subscribe button and subscribe to our YouTube channel to never miss another update. So let us begin. So let us take a look at the agenda for today's session. We'll begin by understanding what data is, and we'll get an introduction to SQL. Then we'll dive deep into what an SQL developer is, what are his skills, and how you can become one. And then at the end of the video, we will have a demo about SQL. So what is data? Well, data is the fundamental thing that an SQL developer deals with. Data is one of the most important assets in any company that you can think of. Any company or any application that you use needs to store data, whether it's data about its internal usage or about the users of the application. Data is one of the most important things that separates good applications from great applications. Now, there can be many definitions for describing what data is. The simplest one could be that data can be facts related to any object in consideration. Suppose you are storing some information about a customer. So the customer's name, customer's age, income, whatever attributes you find necessary for your application to function is considered a fact about the object being the customer, so on and so forth. Now, what is a database? A database is a systematic collection of data which supports storage and manipulation of data in an easy way. So to put it simply, databases are databases are collection of data that allow you to store data in a way that it's easy for you to query them, to get information out of the stored data and store some relationships between those data. Databases can store data about various different kinds of fields. So you can store data about something as simple as a telephone directory to something as complicated as an entire social media network. Now the question becomes, why do we need database? I mean, you can store data that you want to store in an Excel file or a simple text file as well. Well, there are many reasons to use databases over these things. If you are going to store really small amounts of data, then it's probably fine to use text files or Excel files. However, as soon as you start getting a lot of data, databases become a necessity more than an option. So one of the major reasons that you might want to use databases is if you are managing a really large amount of data. As you are managing large amounts of data, you need to establish certain characteristics for the data. You need to establish the relationships between the data. You need to store them and retrieve them in a very efficient manner. And databases do just that for you. You need accuracy as well. You do not want your data to be an invalid state. So to give you an example, if you are storing data about a customer in an Excel file, there's nothing to stop anyone from opening that Excel file and adding some invalid information like the age being -17 or something like that. Now you could in theory add some password protection to that file. However, one of the things that's really important in distinguishing between Excel files and databases is that even though you know the password and you log into the Excel file, the issue becomes if you mistakenly enter an invalid data, then it becomes really difficult when you're managing large amounts of data to figure out where that mistake is and how to rectify it. Then comes ease of data upload. Databases make it really easy and really flexible for you to upload some data that you want to do. So for instance, in case you have large amounts of data stored in Excel files, it's easier for you than you might think to convert that data from Excel file and store it into a relational database that you might want to store it in a table format, any way you like. You can store it in several different formats in several different database management systems. Multiple people can also edit and view it at the same time. So concurrency is also one of the features of a database. Then comes the topic of security. When you're dealing with large amounts of data, one of the most important aspects is security. If the application that you are building stores some information, you need it to be stored in a very concise and secure manner. For instance, if you are storing someone's password, you need it to be stored in a way that no one can access the system that you're working on, or even if they do have access on your system, they can't just open a file and look into the password that the user has. These are the kind of things that databases allow you to do. They allow you to create users, they allow you to manage access to certain rows, certain databases, certain fields. There's high level of security in any database that you use, which is something that lacks in text files and in Excel files. And then there's data integrity. Data integrity is also one of the most important aspects when you're storing data, at least for a large corporation. You do not want your data to have compromised integrity. Now, when you're talking about data integrity, what we mean is we want our data to follow certain rules. For instance, if we are storing some data about a customer's age, we want it to be above 18 years of age. These are the kind of restrictions that you can put in when you're using a database, but not the kind of restrictions that you can put when you're using an Excel file or a text file, because any user can just open it and enter invalid data, either maliciously or just out of absent-mindedness. So databases help you in preventing your data losing its integrity, which is one of the most crucial aspects of any database system. Now let's talk about database management systems. One of the common misconceptions is that databases and database management systems are the same thing. Database management systems are usually a program or a collection of programs that enable you to access data, manipulate data, store data and model data the way you want. Now, there are some interesting facts about database management systems. As you can see, database management systems were first implemented in 1960s. So as you can see, a lot of work has gone into database management systems, and they are still around us. They are still being used. They are still being improved every day. Charles Bachman's Integrated Data Store, which is shortened into IDS, is considered to be the first database management system in history. And today's database technologies have evolved. A lot of work has gone into them, and there have been a lot of radical new ideas that have improved the way we store, retrieve, and manage data. Now let's have a quick introduction to SQL. So what is SQL? SQL stands for Structured Query Language. Think of it as basically a language that you use to interact with your database management systems. These SQL statements allow you to write queries that can insert data, create databases, create tables, insert data, read data, update data, or get data from your database management systems by defining certain criteria. A relational database is a type of database that stores provided information in a structured manner. So it can store different tables and allows you to define relationships and constraints between those tables. We'll see that in the demo as we get to it. And in case you are not understanding all of this, you do not have to worry about it. Stick with me till the end of the presentation, and I'll guide you to the resources that you might need to get up and running with SQL and becoming an SQL developer. So SQL is often pronounced as SQL. So many people either call it SQL or SQL. Now, relational databases are used to create data models that are in the form of a relational model. Relational models are quite intuitive. You could grasp them and model them inside your head. They're pretty straightforward and they're easy to understand. In relational databases, each record will have a unique ID that is known as a key. There are several kinds of keys in a relational databases, and you do not need to worry about all those kinds of keys. This is just a general information that you might need. And in a relational database, there are columns that hold attributes to hold the data. So for instance, in a customer table, the attributes could be the customer's name, customer's age, customer's salary, and any sort of information that you might want to store in that table. Now, SQL comes in several flavors. These are some of the database management systems. These are relational database management systems. Systems such as MySQL, Oracle, Microsoft's SQL Server, often pronounced as SQL Server, and MariaDB. So here's a sample query, so for you to whet your appetite. As you can see, it says select star from student where age is less than 20. So when I was talking about creating or getting data from the databases by defining certain parameters, the age being less than 20 is one of the parameters that I was talking about. The table that we'll be using would be student, and select star means select every information that you can find in that table where the age of the student is less than 20. Now we come to the meat of the entire presentation. Who is an SQL developer? To put it simply, an SQL developer is simply a person who is responsible for managing the data assets of a company using the SQL language. SQL, as I described earlier, stands for Structured Query Language. It's basically a language that allows you to write statements which can perform certain tasks on the databases. Now, how do you become an SQL developer? There are several tasks that are performed by an SQL developer, and if you wish to become an SQL developer, then you need to be comfortable performing these tasks. So let's take a look at them one by one. The first is data modeling. Data modeling basically means getting the entire business requirements that you need for a company to store data, and then creating relational models with creating tables, identifying rows, identifying the columns, identifying the data types that those columns might hold, and identifying the relationships between those tables and the constraints between those tables. Now it might sound very difficult, but don't worry, stick with me till the end of the presentation and I'll show you how you can learn all of these things. These aren't as hard as they may sound. So data modeling is one of the most important tasks that an SQL developer performs. It allows him to transfer the business requirements into the SQL database queries. Then comes data management. Once the data modeling is done, the SQL developer then needs to get the data that the customer wants to insert them, and keep the databases running in a consistent state and figure out how to keep the entire database in a consistent state. This is one of the tasks that are performed by SQL developer. Then comes backup and restore. This is more of a precautionary measure because data is the most important part of an organization. They need to keep the backups of the databases that they have. Now this could be decided by the company about how to go about it. It could be that they take hourly backups, could be that they take monthly backups or weekly backups. Whatever the company policy is, the SQL developer needs to implement those policies, and many a times they do it by automating these backups. And then when the databases go out of network, or something bad happens to the databases that we are working on, we can restore it using the latest copy of the backup that we made. And then comes data migration. It does happen more often than you might think, that you might need to change the database management system, or you might need to migrate the data from one server to another server. This is where data migration comes into play. Supposing you are using a local SQL server and you're storing the data in that, and your company decides that now it's time to move on cloud databases. Now you need to figure out a way to transfer all the data that you have on your local SQL server to the cloud SQL or cloud database. And that's part of data migration, which is one of the tasks performed by an SQL developer. Now let's take a look at the skills that you need to become an SQL developer. You need to know SQL. I mean, it's in the name, SQL developer. SQL stands for Structured Query Language. You basically need to know how to interact with the database management systems, how to issue queries, and also understand how you could write queries that perform the tasks exactly as you need them. Then comes programming. Now you don't have to be an expert in programming. By no means you need to know the entirety of a programming language. All you need to know is how to use a programming language to interface between your application and your database. So suppose you are building a web application, and you're using MySQL, and your web application is PHP. Then you need to understand how to connect that PHP application to your database and how to issue queries, and how to fetch the results and display it to the user. Then comes profiling. Now, this is one of the most important tasks that a SQL developer does. Profiling basically means that once your database becomes of a considerable size, it might start to slow down. It might perform poorly. And now your task becomes to profile it, which is to say, to understand what parts of the database are causing this performance lag. You need to then take a look at the entire databases, issue some queries, profile them, and figure out what are the performance bottlenecks, and try and figure out how you can remove those bottlenecks and how you can improve the performance. Which brings us to the final point, which is performance tuning. As the name suggests, performance tuning is used to increase the performance of our database management systems. There are several ways to do it, and you need to understand what are the pros and cons of all those ways, and then implement the one that fits best for your need. And now these are the steps to become an SQL developer. So the first thing that you need to understand is you need to be extremely comfortable with SQL. You need to understand how you can issue queries, how you can write SQL statements that translate a business requirement into an entire data query. This should allow you to write queries and get the data back from the database in the desired format and display it to the user, or send it back to the client or the application that's using the database. Then comes getting certified. Now, in today's day and age, certification is one of the most important things that allows recruiters to separate you from the crowd of all the resumes that they get. For a given job, many people will be applying, and if you are certified, you definitely have an edge over the other uncertified candidates. So definitely keep in mind, getting certified does bring you ahead. Then build a portfolio. This sort of ties in with getting the certification. Building a portfolio basically means that you need to build things with the knowledge that you acquired while you are getting certified. Now, this sometimes as so happens that you are asked to build projects when you are getting certified. So even after you do get certified, it's more than important to work with the skills that you have and try and build things that could attract some of the recruiters. They'll look at your portfolio and they'll understand that you like doing these kinds of things, and you might even get job offers because of those. And then finally, after building a reasonable portfolio, apply for the jobs. Start looking for jobs and apply for them, and you have a really good chance of getting the jobs if you perform these tasks. To give you an example, here's a job description of an SQL developer. So they need you to be an SQL expert with the SQL queries. You need to understand how to do joins and subqueries. We'll take a look at them in the demo. You also need to be an expert in creating tables, triggers, views. Don't worry if you don't understand them. As I said, stick with me till the end of the slide, and I'll show you how you can go about learning these things and getting a job as an SQL developer. You do need some medium level stored procedures. Think of stored procedures as basically functions that you can run by issuing just one command, and they'll do an entire list of things for you. You also need to have a good grasp of the concepts of databases. Now, there are several fundamental theoretical concepts about database management systems that you need to understand in order to be very efficient with your database skills. And finally, good communication skills. Here's another job description, and it's quite similar to the previous one, but you do need to understand that several companies might have different requirements from their SQL developers. For instance, here they want you to optimize in-application SQL statements. So this is where the programming part of your learning journey comes in. You need to ensure performance, security, and availability of databases. You need to prepare documentations and specifications that tell the user of the database how the tables are structured and how you can go about doing them. Then there's profiling the server and resource users, and optimizing and tweaking as necessary. This is where it comes to optimizing the servers to perform better than they are. And finally, collaborate with other team members and stakeholders. This is where you collaborate with other people, try and figure out the value that the system should be bringing out, and then use the knowledge that you acquired in that collaboration and use your SQL skills to build databases and work with the team. And now finally, we'll take a look at a demo. So I'm using MariaDB. You can use any database system that you want to use. If you can use MySQL as well, or any other database system that you want. Everything is fine. So we'll be in this demo. I'll try and keep things simple so that everything doesn't go over your head, and I'll try and make you understand what I'm trying to do. So in this demo, we'll be creating a database for a small car inventory database. So for a car inventory application, we'll be building a small database that will have two tables. Each table, first table will contain the make of the car, such as Toyota, Hyundai, or whatever. And the second table would contain the model information about the car, the name of the model, the make ID or the year, and the price, and so on. So let's start. Whenever you're working with a database management system, the first thing you need to see is what are the databases that are already created. So type the command show databases. It's bases with an S, plural. So as you can see, by default, our database management systems comes with 4 databases. These are used by the database management system internally, so you don't have to fiddle around with those databases. Now you can pick the name of your database that you want. Make sure that it's not already existing in the existing databases. So just type the name. To create a database, just type create database, and as you can see, I'm typing the queries in uppercase letters. I'll show you why I'm doing that in a moment. And the name of the database would be car inventory. Now you can name it anything you want, just make sure that you remember what you named it, and end the SQL statement with a semicolon. Press enter, and our query ran okay. One row was affected, which means our database is created perfectly. Now if we run the show databases command again, as you can see, we have a car inventory. We just run use car inventory. Now whatever commands we issue will use this database. This is an important step. Now comes the fun part. Now we'll be creating the tables, and I'll show you what are the keys that we'll be using and why we are using them. The first thing we need to do is we need to create a table named make, which will store the make of the car. Now as you can see, I am typing the create and table words in the keywords in the SQL statement as capitalized, and make is in small letter. This is mostly preferential, but I like to do this to separate the things that I can rename and separate the things that are the keywords. So I can't type any other keyword than create to create a table, but I can rename the table from make to make car or car make or whatever. This is something that I can choose. So to differentiate between those, I like to do it this way. You can choose whatever syntax you like. Now open the brace, press enter, and now we will begin defining the model of our database. So the first thing we need is an ID. Think of an ID as a primary key. So if you have been a student, you know that you are assigned roll numbers. Those roll numbers are used to uniquely identify you. So even if another student in your class has the exact same name as you, you can still be differentiated using the roll number. This is what the ID is for in any database or relational database table. It would be an integer. We do not want it to be null. Null means absence of value. We do not want anyone, as we do not want any student to not have a roll number. And finally, we want it to auto increment, which means as we are entering the rows into our database tables, these IDs are auto generated and they are automatically assigned in an increasing order from 1. Okay, now we need the name of the make of the car. I'm going to store it as a variable character of length 30. And finally, I will define the primary key to be ID. Don't worry if this syntax doesn't make sense. I'm just trying to get you to understand how to issue these queries, and I'll guide you to the resources that you need to learn these syntaxes. Finally, let's close our syntax. I press enter, and as you can see, it worked fine. If it would have thrown some error, that would have been a problem. Since it has not, let's move ahead. Now we will create the table model, which is the last table that we need to create for this demo. Now again, I'll be assigning an ID, which would be the similar thing. It would be integer, not null, and auto increment. Press comma, and now we need to define the things that we need to store in this model table. The name of the model would be a variable character. Variable character basically means it could be somewhere around 30 characters, the name of the car, name of the model of the car, and we do not want it to be null, so it's not null. Then comes price. Now price, I can store it as integer, although you do need to spend more time with the customers and your business stakeholders to understand whether you want to store it as null or a precision value like float or double. And then comes year. Now you can store year as integer as well. I'll be storing it as variable character because I will not be performing any mathematical operations on it, and variable characters allow you to use less memory. We do it not null because we do not want it to be empty at any case, which is why it maintains the integrity of our data. And finally, this is the foreign key. This make ID will contain the information about the make of the car, which will be stored in the make table. I'll show you what that means in just a minute. It has to be int and it has to be not null. Now, one thing to note is that this make ID would have same properties as the ID of the make table. You do not need to add the auto increments, just the integer, and it's not null. And finally, we will define the primary key. The primary key of the table would be the ID, not the make ID, the ID of the table. And finally, and it's done. Now the last part of the table is that we'll be adding a constraint. A constraint basically allows us to enforce some data integrity rules. So in this, what we're doing is we are adding a constraint by altering the table named model. We are adding the constraint and we are naming it car model make FK. FK stands for foreign key. So we will be adding a foreign key on the make ID of the table. Make ID, as you remember, is the attribute that we created when we are creating the model table, and this will be referencing the make tables ID column. And the final thing that we want to add is we want it to cascade on delete. I will show what all of this means in just a moment. Okay, I think that's oh, I misspelled the word foreign. F-O-R-E-I-G. Okay, and another thing that I misspelled, references, I think, yeah. As you can see, typing long queries could lead to issues. As you can see, it's done and our foreign key constraint are in place. So what this means basically is that inside our model table, the make ID will only contain the information that already exists in the make table. So for instance, if I enter a car and I want to add its make, I cannot add the ID 4 or 5 or whatever I want arbitrarily. This would lead to data integrity violation, which we have prevented by adding a foreign key constraint. And what all of these means, I'll show you in a minute. Let's start and insert into the make table. Now we will be inserting into make, and the thing that we want to insert is the name. The ID will be auto generated and auto incremented, so we do not need to worry about it. And the values that I want to insert is, since it's a variable character, I need to store it as a string, and I will store it as Maruti. So it's inserted. Let's store Toyota. Finally, let's store Hyundai. Now that these three things are inserted, let's see, select star from make. So we have three names for the makes of the cars that we'll be storing, and the IDs are, as you can see, automatically generated and incremented. Now what we need to do, we need to insert into the model. Inside the model, we will insert the name of the model, the price of the model, year of the model, and finally the make ID. Now this is where our integrity constraints come into play. I'll show you what I mean in just a second. As you can see, there are only 1, 2, and 3 IDs. So if I try to add a car with ID 4, it should show me an error. Let's see whether it does or not. So I'll be adding Hyundai i10. Let's price it arbitrarily. Okay. And let's say the year is 2018. Now finally comes time for the make ID. So I enter 4, and as you can see that we cannot insert using, oh sorry, there's a, yeah. So the foreign key constraint fails and it disallows me from inserting invalid data. Now if I want to insert the Hyundai i10, I just need to make the make ID as 3, and it does work. Now let's store some other values so that we can run further queries. Let's store i20. Finally, let's store Alto, and let's do it this way. So it works. Let's see, select star from model, and we have inserted everything, and we have disallowed from inserting an invalid data. As you can see, invalid data was disallowed. We got an error, so it works perfectly fine. Now we will be looking at some advanced query. We'll be using something called a join. So suppose that I want to write a query that will show me the name of the model, the make of the model, and the price of the car. So I want the make name, the model name, and the price. I want Hyundai i10 and price 7 lakh or whatever it is. So since these are stored in 2 tables for maintaining the integrity, we need to perform a slightly more advanced query. This is called a join query. So let's do that. So I will show you how to do it. Using the select keyword, I will be using the make table's name, and I will be showing it as make underscore name. I'll show you what that does in just a moment. Now that that's done, I will be showing the model name and model dot price. Now that we have defined what we want to display, let's tell which table we want to use. So I will be using the model table. Press enter, and now we will tell the SQL database management system which is the table column that we want to join on. So to join on, we'll be using the foreign key constraint. Basically we tell it, okay, join on the table named make, and on the column ID on the make, and make sure that it equals the model table's make ID. And here we go. So we have Maruti Alto 7 lakh, Hyundai i10, Hyundai i20. So we have the data that we want to use, and we have it stored in different tables, and just one query allowed us to write it entirely. This make.name is make underscore name. I wrote it because the name attribute might have conflicted, and having 2 names in the same attribute could be a little ambiguous to understand which we are talking about. So that's why I named the column name as make underscore name, and we can do it on the fly. So it's not actually done in the table, it's done right here. Now if you want to look at what are the constraints that you have laid on the table, basically write this command. We will see what are the constraints that are on our make table. So we'll be selecting the column name, and the constraint name from information underscore schema. This is a table that has been already created, or this is the database that was already created and used by our database management system. It's called information schema, and we will be using the key column usage table. This is maintained by the database management system, so we do not have to do anything. And finally, we tell it the name of the table that we want the data for. So we go where table name, let me write it, table name equals to, and the name of the table that we are using here is the model table. And as you can see, we have a primary key constraint on the ID attribute and a foreign key constraint named car model fk, which is called make ID. Now I'd like to show you what we did when we applied the foreign key constraint and added the on delete cascade. So what it actually means is that, let me show you. We select everything from make, select everything from model, and now what I want to do is when I delete the Hyundai row from our make table, the model table, every car related to Hyundai should be deleted automatically. So to do this, you basically have to just issue a command like this: delete from make where ID equals to, and the ID for the Hyundai is 3. I press enter. Now let me see, and as you can see, every car associated with the Hyundai make has been removed. This again enforces the integrity constraints, and as you can see, the Hyundai row is deleted from here as well. Now finally, I'd like to show you how you can remove a foreign key constraint. So for instance, this, if you placed an incorrect constraint, how you can go about deleting it. So it's quite simple. All you have to do is type the query alter table. The name of the table on which we have placed the foreign key constraint was called model. You type drop foreign key, and the name of the foreign key, as we can see here, is car model fk, car model make fk, and I press enter, and this is done. So now let me go up and see if the foreign key constraints are still there, and it's removed. So these are the kind of tasks that a SQL developer needs to perform. Don't worry if you don't understand it. I'll show you now how you can go about doing it. So let's go into this. So let's look at the things that you can use for further learning. So whenever I think about learning, Benjamin Franklin said it best when he said, an investment in knowledge always pays the best interest. So if you want to learn more, our company Intellipaat provides we have a blog on which we write a lot of content about a lot of technologies, SQL included. So you could take a look at that, get a grasp on the basics of SQL. Or if you're more of a visual learner, you could use the YouTube platform. Our YouTube channel is filled with great content. You could learn a lot of technologies, again SQL included. You could learn several kinds of database management systems, and you can understand these things in depth for free. Now, since this is done, if you want to get certified, Intellipaat does provide a great course on SQL. We use the MS SQL server, and you get certification which is accredited by Microsoft. You get a lot of content here. You get 16 hours of instructor-led training, 16 hours of self-paced. You get exercises and project work, as I told you before. This is really helpful for you to build your own portfolio, build your own skills. You get certification as well as job assistance. You get flexible schedules and a lot of other things as well, such as lifetime access, free upgrade. If ever the course content changes, you can just upgrade it without any hassle, and you get 24/7 lifetime support. There are a lot of things that you will be learning here. You will be using the MS SQL, and if you have a few questions, you can take a look at the FAQs. These are the course contents. We'll be learning the SQL. We'll be learning join tables, just like I showed you right now. If you didn't understand it, you will learn it using the certification. You will deep dive into the SQL functions. You will learn subqueries, functions, stored procedures, user-defined functions, you will learn Transact SQL, you will learn a lot of other things as well. And finally, you will learn the Microsoft courses study material. So you will be well on your way to become a really good SQL developer. These are a few of the projects that you'll be building. You'll be building 3 projects in the certification, which is quite good to make your portfolio and start applying for the jobs. Here's a sample that you can take a look at if you wish to feign your interest in the SQL certification. Here's what the certificate would look like. As you can see that it helps you get passing in the SQL server certification exams as well. So it's quite helpful for you, and this is the course that has been recognized by several MNCs like Ericsson, Cisco, Cognizant, and so on. You can look at the reviews, as well as a lot of reviews have been left by the people who used this content, and it's one of our most well-reviewed courses. As you can see, there are a few FAQs. So if you have a few questions, you could take a look at the FAQs and understand what are the kind of questions that they are answering. But I understand if your question is not mentioned here. Now, as a thank you for sticking with me till the end of the slide, here's a coupon code especially for the YouTube viewers. So you can use it today, and it's valid for today. You could use YouTube 30 on any course that you want and get flat 30% off on any course that you want. This is especially for you, for the people who are watching this video live on YouTube. And if you have any queries about anything and your queries do not seem to be addressed in the FAQs, you can contact us at any time you want. We have 24/7 chat available with our course advisors. You could contact us at sales@Intellipaat, and you could contact us via the mobile numbers that are being listed on the screen here. Our course advisors are always ready to talk to you. They are more than willing to spend their time with you and help you get the best course that you could use to further your career. With that, thank you very much for sticking with me till the end of the presentation. Hopefully you've learned something, and hopefully it's been as fun for me as it is for you. Thank you.